words that we haven't had before. And we're going to also have, we're going to have to make sure we know which rule goes with which point of concurrency. So the first thing we're going to look at is the altitude and the median and what those mean. So before we define them, I want you to draw this triangle. So right now, when you draw the triangle, only draw points A, C, and D. Okay? A to C to D. Make a triangle without any of those other extra lines. Okay? Make it look just like that triangle without the extra lines. And then label it. Have your point A at the top, C in the bottom right, and D in the middle. Okay, does everybody have that? So the first thing we're going to talk about is the altitude. So have you heard that word before?
Yes.
Okay, where have you heard it?
Like airplanes.
That's what I think of too. Airplanes, right? I'm getting some altitude. Is that from Rocky and Bullwinkle? I think that's a Rocky and Bullwinkle.
I heard it again.
Okay. It may be on a game too, I don't know. But altitude means the height, right? Think of an airplane, they're getting altitude, they're getting taller. So the altitude of a triangle is the distance from the highest point to the lowest point, is my altitude. So definition of altitude is from the highest point, which has to be a vertex, to the lowest point, which will be the other base. From a vertex to the base. That's an altitude. Highest point to the lowest point. Now, there are a couple of rules about altitude. So, like, right here in this triangle, look from A to D. Is that a line that goes from the highest point to the lowest point?
Yes.
It does, but it's not an altitude because it doesn't get there as quickly as it can. Right? This is kind of like it's slanting. It's taking forever, or it's taking longer to get there than it would be if you just went straight down. Okay? So this distance here from A to E is the altitude. So a property of altitudes is they always must be perpendicular to the opposite side. So altitudes, you'll always see this right angle. They have to be perpendicular. Altitudes have to be perpendicular. Have to have a 90-degree angle. Okay, any questions about what an altitude is or having to identify an altitude? Now, one thing I want to talk about with altitudes before I go on is how many altitudes does this triangle have?
2. 3.
How many does it have drawn? 1. How many could it have?
2. 3.
It could have 3.
Yeah.
Absolutely.
A, C, A to D, and A to
If
D.
I drew the triangle and I turned it like this, now the highest point would be the vertex C, and the altitude would go straight down to D. Right? It would be somewhere here. And a straight line down to D, that would be my altitude for the triangle. So that's the second one. And then what if I turn the triangle in this direction? Now D is still the highest point. And then if I had to drop an altitude, the altitude would be somewhere in here. All right, I'm going straight down, forming a 90-degree angle.
So each point can have an altitude.
Every vertex has an altitude from it. If I was to turn the triangle to make that point the highest point, that could become an altitude. Absolutely. Okay, any questions about altitudes? How to find them, what they look like? Okay, now the second vocabulary word we're looking at is a median. So have you ever heard that word before? Median.
Yes.
Okay, where have you heard it?
I remember.
Yeah, like mean, median, and mode. Probably where you've heard it before.
Yeah.
What a median is, in terms of a triangle, it does kind of mean the same thing. It's about the center of the triangle. We're finding the median. But here's the definition. A median is a line that goes from a vertex, which is an angle. So median goes from a vertex to the opposite side. And then what happens when it gets to the opposite side? Look what it's done.
Evened it out. It's like a grid.
It's bisected it, right? Cut into two equal pieces. So medians, they always bisect a side and they start in the vertex. Or start in a vertex, not the vertex. A vertex. So on this triangle that's already drawn, there's only one median drawn. It starts in the vertex D, going to the opposite side B, cutting it into two equal pieces. Okay, but how many medians are there really in this triangle?
One,
There would be
two,
three again. I could go from any vertex A, I could draw it to the opposite side here, DC, and when it meets that opposite side, it has to cut it into two equal pieces. So I may not have done it exactly correctly, but it should cut into two equal pieces. And then I could draw one from C here that would go through and hit the point AD and cut it into two equal pieces. All right, those would all be medians. Now look at what happened. Where did all my medians meet at? They all intersected here in the middle. This is going to be a point of concurrency that we're going to be looking at later on. The altitudes, did they look like they intersected somewhere? Not really, right? They didn't have an obvious place they intersected, but they do intersect as well, and we'll look at those when we get there. Because, again, another hint that tells me is that altitudes always have to have a right angle. They are perpendicular. So the line here that goes straight from the top C, straight down, to the opposite side, would be side CE. Okay? Any questions on finding the altitude? Okay, the second part, let's find the median. So again, remember, a median has to start in an angle and go to the opposite side, bisecting it. So pick a number 1 through 5. It's 5. Pick a number 1 through 4. It's 1. Alex, which line is a median? BD. What do you guys think?
Yeah.
BD, it starts in a vertex, right, in an angle, goes to the opposite side, and it cuts that side into two equal pieces. So I agree. That is the median. So we just talked about all the medians met at a single point. So like right here, they've drawn a triangle ACB. And you can see when they draw all these medians, they all meet at point G. So G is a point of concurrency. Now, here is the rule that is true for the concurrency of the medians. From A to D, that is one median. Well, the distance from A to G is the same as 2/3 of the entire line. So you see these rules? AG is equal to 2/3 of the entire line. That's also true here. CG is 2/3 of that entire line, which would be here, CF. And then right here, BG is 2/3 of the entire line, BE. So the distance from the angle to the point is 2/3 the entire distance from the angle all the way to the opposite side. So you need to write down those rules somewhere. All right, it doesn't have to necessarily say AG equals 2/3 AD, but you need to write for concurrency of medians. You need to say that the total distance is equal to 2/3 times the distance from the angle to the point of concurrency. So that means that the angle to the point is longer than it is from the angle to the opposite side. Okay, so this problem This is going to be your typical problem. It wants to know what's the length of segment JN. Okay, so we can see that JN is a median because it goes from the angle to the opposite side, cutting it into two equal pieces. And all of these lines are medians that meet at point Q. So the distance from J to Q is 2/3 of the entire distance. Right? So we could say that, here's what we would use. We could say that JQ is equal to 2/3 of JN. Right? JN is the bigger angle, or the bigger line, sorry. So we know that it has to be cut into a smaller piece, 2/3. Okay, so now we're going to plug in what we know. Do we know what JQ is?
Yes.
What is it?
18.
18, it tells me. So I'm going to plug in 18 for JQ. So that tells me 18 equals 2/3 times JN. And now I only have one unknown. So I'm going to solve it. I'm going to solve for JN. So different ways you can do it. You could divide by 2/3, right? And if you have a calculator, that's fine. So I would divide both sides by 2/3 to get rid of it. Or I don't have a calculator. So what I would do is I would multiply by the reciprocal. I'm going to multiply by 3/2.
Wouldn't 2/3 as the decimal be 2.3?
Nope, it's going to be 0.6 repeating. So 3/2 and 2/3 cancels. That leaves me with JN equals, and then 3 times 18 divided by 2 is 27. So this tells me that the entire distance from J to N has to be 27. So right here, what I'm drawing in yellow, that is 27. Now does it ask me for, it does. It asks me for all of JN, right? So it says, what's the length of JN? The length is 27. Okay, these problems though, they could kind of get cute. They could ask you, what's the distance from Q to N? Just this small piece. Well, if you know that this bigger piece is 18, and the whole thing has to be 27, you could do 27 minus 18. And you know that this smaller piece then has to be 9. Right, so just be prepared for those kinds of questions as well. And you're wanting to balance a triangle on something. Okay? You're taking a triangle, trying to balance it. Well, how do you know where to put the triangle so that it's balanced?
The center.
Okay, well, what's the center?
Median.
Triangles have lots of centers, right? There is no just one good center of a triangle. Well, it turns out whenever you want to balance a triangle like this, you need to place the pressure point on the centroid. Okay?
Center.
Centroid. That sounds like center, right?
Close enough. I got it right.
But do you know how you find the centroid of a triangle?
Find the median. I reckon you're about to show us.
A centroid is the point of concurrency of the medians, right? So if I draw a median here, a median here, and a median here, those three medians meet at their point of concurrency, Q. That point of concurrency, Q, is called the centroid. It's the center of gravity. So that's what would balance the triangle. So, hey, that's pretty cool. There's really no problems to do with that. I just thought that's interesting. So, we'll throw that in there.
I'm starting not to like that those pictures.
Okay, so the point of concurrency of the medians was called the centroid, right? Now we're going to be looking at the point of concurrency of the altitudes. So if I draw the three altitudes, which is the distance from the highest point down to the bottom of your triangle, from the highest point to the bottom of your triangle, from the highest point to the bottom of your triangle, here, those are all called altitudes. Now, where your altitudes meet is called the orthocenter. Now, orthocenters can happen in random places depending on the kind of triangle you have. So if I'm looking for the orthocenter of an obtuse triangle, that would be a triangle that has an angle bigger than 90 degrees. Then the orthocenter is going to happen outside the triangle. Every time I have an obtuse triangle, the orthocenter happens outside the triangle. Whenever I have an acute triangle, that means all the angles are less than 90. Then the point where the altitudes meet is always inside the triangle. And then if I have a 90-degree angle or a right triangle, then the point where the orthocenter is always on that right angle. Okay? It happens on the triangle. So that's kind of what you have to do, is you have to write down those notes. So this is what I want us to write. The orthocenter of an obtuse triangle occurs outside the triangle. Then we're going to talk about acute triangles. The orthocenter of an acute triangle occurs inside the triangle. And then the orthocenter of a right triangle occurs on the triangle.